Good morning, everyone.
Good morning, ma'am.
Morning, ma'am.
Whereas after so long week, you were absent, no? I think last week.
Yes, ma'am.
Why?
I'm mom बीमार थे.
Okay, so what are the points we are having in the third chapter is? I will write down all the points. So we will start with one by one. The first two we have already covered. First is Gauss elimination method. Second is LU decomposition method. And third is Gauss-Seidel method. Fourth one is householder method. Fifth is symmetric tridiagonal, eigenvalues of symmetric tridiagonal matrix. And the last one is power method for eigenvalues. These are two related to eigenvalues. Okay. The first two we have already covered. I will give you the page number which is available in your recommended book. This is page number 288 and this is on page number 297. This is on 295 and this is on 293. Please note down this so that you can have a notes for this because I haven't shared you the notes of third chapter. So you can take down the notes from this recommended book. Okay. So the first two we have already covered. Now let us go for the next one, that is Gauss-Seidel method. In this Gauss-Seidel method, we are again going to solve the system of linear equations. Okay. Suppose again we are having a n cross n matrix type. Okay? That means we are having n equations and n unknowns. Actually, this is with like a11 x1 plus a12 x2 a1n xn. So next is the next equation a21 x1 plus a22 x2 plus so on a2n xn. In this way we can have n equations and n unknown. That is, this is say an1 x1 plus an2 x2 plus so on. The last is ann xn is equals to bn. These are n equation in n unknown. Okay? We are having n equations in n unknown. So now how to solve by using Gauss-Seidel method that we are going to see in this lecture. Okay. So what we have to do, in this case, first we will divide by a11. Rather, whatever may be the coefficients of x1, we have to divide by the coefficient of x1 to the first equation and coefficient of x2 to the second equation and coefficient of x3 to the third equation. Whatever may be the coefficient, you have to divide this whole equation by that coefficient of for first equation it is x coefficient of x1, for second equation it is coefficient of x2 and like that. Okay, so what we have to do, first we have to divide by you will come to know how you will get the answer, that is To solve this system of equation means what? We have to get the answer of this xi. Right. So first we will divide by the coefficient of x1 to the first equation. So we can write this is in the form of x1 is equal to, right? We can write this as x1 is equal to, what will be the sign if we are going to divide it by a11. So it is b1 upon a11 minus a12 divided by a11 x2 minus a13 divided by a11 x3 and so on. The last will be with negative sign minus a1n divided by a11 xn. Right. So in this way, if we are going to assume the values of x2, x3 and so on, if all these values are, I'm going to assume this as 0, so we will get the value of x1 as b1 upon a11, that is approximate value. Later on with the some iterative procedure, since actually Gauss-Seidel method is also called as a iterative method. Okay. In this iterative method, what we have to do in the first equation, whatever we got by dividing by the coefficient of x1, the terms which are there x2, x3 and so on, we have to assume that the coefficient of these to be equal to 0, and we get the value of x1 as b1 upon a11. In the very similar way we have to do for the x2 also. We have to divide by the coefficient of x2, that is a22, minus what is the next term here, this is a21 divided by a22 minus a23 divided by a22 x3 and so on. The last is a2n divided by a22 xn. Correct? So in this way we have to follow the procedure, and for the last equation xn is equal to, what will be the last equation? The first term will be bn upon ann minus what is the first term here in the equation is an1 divided by ann. The coefficient of this will be what? x1. In the very similar way, the next term is an2 x2 divided by ann and so on. The last one will be an and minus 1 divided by ann. Xn minus 1. Okay. Are you getting what we have done? For the first equation, we have divided it by a11, making sure that the coefficient of x1 should not be equal to 0, then only we can divide. And the next, the coefficient of x2, whatever it may be, a22, we have to divide by a22 for the second equation. And in general, now we can have the equation, the above equation can be now in this reduced form. Okay. So now you can see that if I am going to equate this x2, coefficient of x2, x3 and all 0, so I am getting the value of x1, that is first approximation or zeroth approximation as b1 upon a11. So here whatever the value of x1 I am getting b1 upon a11, that I have to put in the next equation, and here you can put up the value of x1 as b1 upon a11, and the next term you have to equate it to 0, x3, x4 and so on. What will be the term for the next is, in the x3 you can put up the whatever the values you are getting of x1, x2 from the last two equation, put it in x3, and then you have to equate all the next term to be 0, right? In the first equation we have equated x2, x3 and so on 0, and here we have equated this x3 and x so on. So here now we can equate the x4, x5 up and so on. We can have up to xn, all the terms are 0. Okay, so here you are getting the value of x1, x2, x3 from the last equations, and then we can put up the values and you can get the value of xn. Are you getting what we have done?
Yes, ma'am.
Okay, so in this way, this is what only the first step, as it is called the iterative method. So we can assume, or we can say these are the x11. Okay, we can name it as say x11, that is the first approximation we got, x21, x3 1, and so on, xn 1. That is the first approximate values of those unknown we are getting. Okay. Now we have to follow the same procedure. Now, how to follow the same procedure? We have to do uh, the similar procedure to find out the next iteration. Okay. We are knowing now the first approximations, and now we have to find out the second approximation with the help of a first one, right? Now you can I will write down this so that you can understand. This will be x12, the value of x1 with 2. What do you mean by x12? It is the value of x1 which is obtained in the second iteration, and it will be equal to the whatever the equation we have written. It is just like a same which we have written just now, b1 upon a11 minus a12 divided by a11. But what is the change here? Instead of using the x1, x2, x3, so here we are going to use, instead of x2 we will use x2 1. Okay, the values which we get in the first iteration we are going to use in for the second iteration. Getting me how to calculate this second one? Okay, in the very similar way, minus a13 divided by a11 minus a13 divided by a11. What is the next term here? X3. Okay, instead of x3 we have to write it x3 1, which means that it is the, we are using the first iteration values to find out the value of a second iteration term. And in this way, the last term we can write it as a1n divided by a11 x n 1. Okay, so now you can write the second equation as x22, which means the value of x2 which is obtained in the second iteration with the help of first one, that is b2 upon a22 minus the first term is a21 divided by a22, and here it will be x1 1. Okay, here first we are going to use x1 1. You can see here the value of x2 we have evaluated with the help of this. So whatever the equation we have obtained for the first one, what we have to do, we have to do the changes here in the values of x1, x2, x3 itself. Okay, so in this way we can get the last term maybe minus a2n divided by a22 xn raised to 1. Okay, getting me? So last equation may be xn 2 is equal to is bn upon ann minus a1 an1 divided by an and x1 1 minus an2 divided by ann x2 1, and so on, an n minus 1 divided by ann, and here it will be xn minus 1 1. Okay. So whatever the values we are getting for the first iteration, we have to use it for the second iteration. This is what the procedure we are going to follow for Gauss-Seidel method. Hence, this Gauss-Seidel method is also called as a iterative method. Okay. Now I will write down the formula for the or the iteration for the nth approximation. Okay. Last one we will write directly, that is x1 raised to n plus 1 is equal to, we can write the last iteration. After following the nth approximation, we can have x1 raised to n plus 1 is equal to b1 upon a11. This will be as it is. Correct, minus the next term. What is the next term for this one? a12 divided by a11 x2 raised to n. That is the values which we have obtained for the nth approximations, and so on. Similarly, we can do the procedure for x2 raised to n plus 1 is equals to b2 upon a22 and the next one. And the last will be xn raised to n plus 1 is equal to. Okay. So let me write down the terms which we get here is A21 divided by A22 x1 raised to n, and so on. The last will be bn upon ann minus an1 divided by ann x1 raised to n, and the next term. So in this way we have followed the n iterations, and we have got the values of x1, x2 and x3. Okay. Are you getting what is the procedure? First, we have to divide by the coefficient of x1. For the second equation, divide by the coefficient of x2. And for the third equation, divide by the coefficient of x3, and so on. And whatever the values you are getting, what you have to do for the first procedure? First, we have to equate all the x2, x3, and all equated to 0. Simply, we will get the value of x1 as b1 upon a11. So, this value of x1 you have to use in the second equation, keeping all x3 onwards will be equal to 0. And for the third equation, what will be the resultant? x1, x2 you can get, and then you can get the value of x3 from this, and x4 onwards, all the terms will be 0. Okay. So in general, now from the each equation you are getting one value, x1, x2, x3, and so on. So we have to put this all values in the xn, and you will get the values of x11, x12, x13, and so on. So this means that this is what the values of x1, x2, x3 we have obtained from the first iteration, and you have to follow the same procedure for finding the values of x1, x2, x3 in the second iteration. Getting me?
Yes, ma'am.
Okay. So what we have to do is first we'll solve an example so that the idea will be clear. Okay, write the example. In x1 minus x2 plus 2x3 is equal to 6. This is the first equation. Minus x1 plus 11x2 minus x3 plus 3x4 equal to 25. Next is 2x1 minus x2 plus 10x3 minus x4 equal to minus 11. 3x2 minus x3 plus 8x4 equal to 15. Okay. So what is the first procedure? First we have to divide by the coefficient of x1, then coefficient of x2, and so on. So you can say now solving for the values, for getting the values of x1, x2, x3 in the first iteration. You can say the step 1. Solving for getting the values of x1, x2, x3, x4. Since we are having 4 equation in 4 unknown. Okay. Have you written this?
Yes, ma'am.
Okay. If you have written, let me write this x1 equal to. X1 equal to what will be the term? X2 divided by 10 minus x3 divided by 5 plus 3 upon 5, the constant term. X2 is equal to x1 upon 11 plus x3 upon 11 minus 3x4 divided by 11 plus 25 by 11. Next, x3 is equal to x1 divided by 5 plus x2 divided by 10 plus x4 by 11, 10 minus 11 by 10. X4 is equal to minus 3 x2 divided by 8 plus x3 divided by 8 plus 15 by 8. Okay. Now choose the initial approximation as 0, 0, 0, and hence we get what we will get if I am choosing x2, x3 is 0. So I will get the value of x1 is equal to 3 by 5, which is equal to 0.6. Okay, using the value of x1 here, 0.6 divided by 11, and a remaining all term x3 onwards we have to equate it to 0, and this 25 by 11. So x2 value I can write it as 0.6 by 11 plus 25 by 11. Calculate this and tell me what is the answer for this.
Ma'am, please repeat the procedure.
Yes.
Ma'am, repeat the procedure. What we have to take initial values of x1, x2, x3, x4, 0.
No. We have for the first equation x1, whatever the constant term we have, this constant term we have to keep. All other terms will be equal to 0. That means coefficient of x2, x3 and x4 all will be 0. Okay.
Okay, ma'am.
Just like the procedure, what we have done in the procedure, you can see here. Okay. Here b1 upon a11 we have to take. All other coefficient of x2, x3 onwards, all the terms will be 0. In the second equation, whatever the equation of x1 we have got, x1 is b1 upon a11, that we have to take for the second equation, remaining terms will be 0, x3 onwards. In the third equation, x4 onwards, all are 0, we have to use x1 and x2 for calculating the value of x3.
Ma'am, x2 is 2.3272.
Okay, 2.3272.
72.
Okay, now these values of x1 and x2, what we got? x1 is 0.6, x2 is 2.327. We have to use for finding the value of x3. So minus the value of x1 is 0.6 divided by 5 plus value of x2 is 2.327 divided by 10. And in this term, we have to keep x4 is 0. Okay, in every step, you are getting one value. So what will be the value of x3 from this?
Minus 0.9872.
Okay. So here we get the value of x3 is minus 0.9870. Now you got the value of x1, x2, x3. All values you can use in the fourth equation so that you can get minus. So now whatever the values you have written x1, keep it as x11 since this is what the values we have obtained for the first iteration. Now x41 will be equal to minus 3, value of x2 we have to write here, divided by 8 plus value of x is minus that 20 divided by 8 plus 15 by 8. Okay, so in this way, the first approximate value of x4 we are getting as 0.8789. Yes, you get the same value x4 equal to 0.8789. Hello, am I audible?
Yes, ma'am, it is right.
Okay.
I got 0.879.
Whatever it is, 0.87 is common, so that is okay. Now we have to do the same procedure for the second iteration, that is x12. Now we have to use these values. You can write these values as x11. This is what x12, sorry, x21, x31, x41. So write these values so that we can use these values of x1, x2, and x3, which we obtained for the first iteration. You can use it in the second step. And write the step 2. That means in the second iteration we have to use again the same equations. But what will be the change here? Instead of values of x2, we have to write it as x21. Okay. Same equation you have to write it once again. These equations. What is the change? X1 is equal to x21 divided by 10 minus x31 divided by 5 and so on. Write these equations and then we will solve. X1 equal to x21 divided by 10. Next is x31 divided by 5. 3 by 5. Okay, now here you can use whatever the values of x21, x31 we got. Okay. हे जे काही values असेल तुमचे x21 आणि x31, you have to use these values. Okay. Let me write down here values of x11 as it is 0.6 and this is 2.327 and this is minus 0.987 and the value of x4 we have obtained 0.878 and 878 something. Okay, now we have to use these values. Value of x21 we have to keep here 2.327 divided by 10 minus x3 is minus become plus 0.987 divided by 5 plus 3 by 5. Okay. Now you can say this is what your x1, 2, that is value of x1 we have obtained in the second iteration.
Is it 0.514?
At this point, I think you should calculate once again.
Zero point 0.6353.
Okay, let me calculate so that I will get the answer. Point.
And is it 0.614?
Let me check because whatever the answer I have calculated yesterday, it was 1 point something. So let me calculate once again so that it will be correct.
Ma'am, 1.0301.
0.030.
I think there is some mistake in the values of eras and next अजून कोणी सांगितलं होतं व्हॅल्यूज
Me, ma'am.
वैष्णवी का
Bhagyashree.
भाग्यश्री
0.6353.
okay you must check once again so that because I have the values it is in 1 point something so check it once again I am also checking this one okay I am getting this answer as 1.029 yes anyone else getting the same answer it should be just like 1.0 should be common other maybe because there will be some difference in the calculations and we can write the values 1.03 or 1.02 like this yes
Ma'am, 1.0301.
okay 1.0301 okay so here we got the value of x12 that is the value of x1 in the second equation now we have to follow the same procedure use the equation that is x2 is equal to x2 equal to x11 divided by 11 x11 divided by 11 plus x31 divided by 11 minus 3x41 divided by 11 plus 25 by 11 okay now whatever the values we have put up this and tell me the value of x2 that is value of x2 in the second iteration
Ma'am, is it 1.998 something?
1.9 right
Yes, ma'am.
something 1.99 yes anyone else getting because I have got the answer as 2.03 something no doubt 1.9 is also very nearer to 2 so that is also okay this 1.9 you can approximate and using the our rounding off you can equate it to 2 yes anyone getting the answer as a 2.0
No, ma'am, 1.998.
okay
It's 1.998, ma'am.
has commented 1.998 no doubt this 1.998 is very nearer to no doubt it is not 1.9 1.998 we can equate it and we can say that is 2.0 because we want to come to our correct answer right so values of x1 x2 x3 cannot be 1.99 like this so we can equate it to 2 since we are using the approximation okay so this may be 2 something next we can calculate the value of x3 is equal to on the equations we have x3 is equal to what is the equation minus x11 divided by 5 plus x21 divided by 10 plus x4 1 divided by 10 minus 11 by
10.
right, x3 is equal to um, x3. Calculate and tell me after putting all these values x3 is equal to, first answer is minus 0.98. Okay, so value of x3 2, that is value of x3 in the second iteration we got it as calculate and tell me, and up to then I will write the fourth equation x4 equal to minus 3x2 1 divided by 8 plus x3 1 divided by 8 plus 15 by 8, which is x4 2 equal to,
Ma'am, is it minus 0.899?
x3
X3.
you are saying
Yes, ma'am.
point
Ma'am, it
8
is minus 0.899.
99. Okay. What about x4? I think everyone is only taking the point, just like only two significant digits from the number. So whenever you are going to solve iterative method example, so for iterative method example, you have to at least follow the four significant number. Suppose it is like 2.372. So you have to take all these number for your calculations. Don't take only 2.3. Okay, whenever you're going to apply the iterative procedure or in a whole paper of numerical analysis, you should at least take four significant digit for calculations. If you take only 2.3, it will not get you will not get a correct answer.
Ma'am, X4 is 0.879.
Okay, so these are the values we are getting for the second iteration. Since still we are not getting any exact value, it is zero point 0.8, zero point 0.8, and here is 1.03. Right. So for that, let us proceed once again so that we can get the exact values for that. Which means we have to follow the step 3. In the step 3, again we have to write the same equations. x1 is equal to, now it is in terms of x2 2 divided by 10 minus x3 2 divided by 5 plus 3 by 5. x2 is equal to x1 2 divided by 11 plus x3 2 divided by 11 minus 3x4 2 divided by 11 plus 25 by 11. x3 is equal to minus x1 2 divided by 5 plus x2 2 divided by 10 plus x4 2 divided by 10 minus 11 by 10. And x4 equal to minus 3x2 2 divided by 8 plus x3 2 divided by 8. plus 15 by 8. Calculate all the answers and tell me the values of, we can say this is the third iteration. So hence the values we can say it is x1 3, x2 3, x3 3, x4 3. Again, consider you have to at least use the 4 significant number whenever you are going to follow the iterative procedure. Don't use only 2.3 or just like 0.8 numbers. You have to use all the 4 significant digits in using or in calculating the values of x1, x2, and x3.
Ma'am, x13 is 0.9828.
0.9828.
28.
Ah,
Ma'am, x23 is 2.044. Ma'am, x32 is minus 1.015.
okay. What about x4 last? I will write it is 0.99 something, or we can equate it to 1. If the question is for 7 marks, no doubt you are not going to appear for the physical exam. You have to follow the step 4 also. Okay. Following the step 4, you will get the values of those terms as x1 4 is equal to 1, x2 3 is x2 4 is equal to 2. That means we can equate, we can approximate, and we can get the value of x3 4 equal to minus 1 and x4 4 equal to 1. Now you have to cross check whether the answer is correct or not. That means the values of x1, x2, x3 we can say it is exact solution of the system. You can write it as 1, 2, minus 1 and 1. And if you want to cross check, you have to put again back in your equation any one of the equation you have. Putting in the first equation, I can get it is 10 minus 2 minus 2. So 10 minus 4, it is 6. So whatever the answer we got, it is correct. Yes, so simply we in the third chapter, we are going to study what are the methods to solve the simultaneous equations, and two methods, which is symmetric tridiagonal power method, are for eigenvalues. Okay, one more example you have to write for the homework. If you have completed, I will write this example. You have to write it and then solve it for homework. Okay, write the example for homework. 2x1 plus x2 minus x3 is equal to minus 1.
Ma'am, please repeat.
Okay, I will write 2x1 plus x2 minus x3 plus x2 minus x3 equal to minus 1. The second equation is x1 minus 2x2, 3x3 plus 9. Three x1 minus x2 plus 5x3 is equal to 14. Try to solve this example by using our Gauss-Seidel method, iterative method. See, you have to solve the example since as you are going to appear for MCQ examination, you will not get the answer of this question directly on the Google. So you have to solve this and must have a practice to solve the examples. Since you can ask your seniors that what was the result of numerical analysis for the last semester. It was an MCQ examinations.
हेलो मैम।
Yes.
मैम 1 मार्क का एक एमसीक्यू रहेगा तो उसको इतने बड़े बड़े सम्स पूछेंगे।
No, they can ask you for the first approximation, no? First approximation okay for first one, right?
यस मैम।
If you have done, if you're not having any doubt, you can leave the meeting. In the next lecture, we'll go for the next method, that is householder method. and the next two are remaining. Only 3 points are remaining from the numerical analysis and 3 points from the integral equation. So start doing your study. Be prepared for examinations.
Yes, ma'am. Thank you, ma'am.
Thank you.